finding the domain of a function is a very common mathematical problem. Each of them is slightly different. You're looking to see which values of x will actually produce a y in a problem. So I have 3 problems right here to look at just what the domain is. They're all slightly different. One's a polynomial, one's a fraction, a rational expression, and one has a square root. So you're going to each look at each one a little differently, just kind of using a little bit of logic to figure out what values of x will not work versus which ones will. So if I take a look at A is a square root, and hopefully we know by now in math that you cannot take the square root of a negative number. So what we need to understand is the expression that I have underneath my square root needs to be a positive number, or it can be equal to 0. So mathematically, when I write that, I need to have 4x plus 3 be greater than or equal to 0. At that point in time, start solving for x. So we're going to have 4x is greater than or equal to negative 3. So x is greater than or equal to negative 3/4. This is the inequality way to write it in interval notation. That means that x, the lowest x is going to be is negative 3/4. The highest it can go is to infinity. You can never equal infinity, so you're going to have a parenthesis to bound that side. And since we can be equal to negative 3/4, we can have a bracket. All right. Moving on to the second one, which is a rational expression. If you recall from rational expressions, the only way that, well, with a fraction in math, the only issue that we see with fractions is if you have a denominator equal to 0. You can have a negative, you can have any other number there, that's fine, you just cannot have the denominator equal to 0. So if we were to take our denominator that we have, which is x plus 5, and set it equal to 0, we will see that our only issue is going to be when x is equal to negative 5. We will not be able to get a y value out. So every other number works. It's going to be a combination then of 2 intervals. One interval that's going to go from negative infinity up until negative 5, as well as, so union with the interval that picks up from negative 5 and then goes to infinity. So that is actually, there's 2 different integrals. There's a break in the graph in this case. And moving on to the last example, this is a polynomial. It is actually a cubic written in a form where I know that the inflection point is at 2, 5, and it's shifted to the right 2 and up 5 with a stretch factor of 3. Basically, we just think to ourselves, okay, if I plug in a number for x and I cube it, can I cube any number? Can I cube a negative? Can I cube a positive and get a number out? And the answer to that question is yes. And since I can get anything out that when I put any number in for x, I can have a domain of all real numbers. So you can write it in interval notation, negative infinity to positive infinity, or with the symbol for all reals.